All right, everybody, welcome to the video here for lesson number 2. So in lesson number 2, we learned about reference angles and how these angles of our triangles can be created by going beyond 90 degrees. So let's just jump right into it here. So number 1 says, on the unit circle, sketch a terminal ray that forms the angle 240. Determine the value of the reference angle, and on your sketch, label the sine of 240 and the cosine of 240. So let's first start by drawing the unit circle, right? It says to draw the unit circle, so we gotta do that first. Here's your x and y axis, and then we're just gonna draw a nice little circle around it. And these are all gonna go out to ones. That is a poor excuse for a circle. Let me fix that. A little bit better. Okay. So to sketch a terminal ray of 240, we already know the initial ray starts here on the x-axis. And then I'm going to turn around. I know I'm at 90 here, 180 here, 270 here, and 360/0 here. So 240 is going to be somewhere in quadrant 3. So I'm going to rotate around and then terminate somewhere here in quadrant 3. Now in class we went over how we can find the reference angles in each quadrant. In quadrant 3, the reference angle is equal to the angle minus 180. So the given angle that we have here is 240. This is my theta. So the reference angle is 240 minus 180. So the reference angle is 60 degrees. I can label that in my picture. That's this little angle here. It also says to label the sine of 240 and the cosine of 240. That's going to be where this terminal ray intersects the unit circle. This point, which I'll call point P, has coordinates of the cosine of 240. Remember, it's always cosine as the x value, sine of 240, because the sine is always the y value. All right, let's keep going here. Number 2. Number 2 says to sketch each of the following angles in standard position and state the reference angle for each. So if I draw 120, and while I have black pen, I'll just draw my x and y axis for all of these. All right, so if I have 120, that's going to be a terminating angle in quadrant 2. So that's going to open up and end somewhere in quadrant 2. The reference angle in quadrant 2, the rule is the angle, 180 minus the angle. So the reference angle for 120 is 180 minus 120. So the reference angle is just 60. That would be this angle here that references back to the x-axis. .320 is going to terminate somewhere in quadrant 4, so we draw my initial ray, go all the way around and terminate somewhere in quadrant 4. Again, the reference angle is how many degrees does it take to get back to the x-axis. So the rule for the reference angle here is 360 minus theta. So the reference angle is 360 minus 320. So the reference angle here is just 40 degrees. That would be this little angle here. .200 degrees is going to be somewhere in quadrant 3, really close to the x-axis though, because if you think this is 180, so when you go all the way around, you want to be a little bit closer to the x-axis than normal. Kind of estimate where your angle is going to be. The rule for quadrant 3 is the reference angle is equal to the given angle minus 180. So the reference angle here is going to be 200 minus 180. So my reference angle is just 20 degrees. This little angle here is 20. 280 is somewhere in quadrant 4, really close to 270 if you think this is 270. So here's your terminating ray. And we're going to come around and be close to 270 like that. The rule for quadrant 4, we just did above, so the reference angle is going to be 360 minus 270. So the reference angle here is 80 degrees. That's this big reference angle here. Being able to find the reference angle is a really important tool for trigonometry. So hopefully you understood that part from the lesson. All right, number 3 says the vertices of a triangle have coordinates of 0, 0, 12, 5, and 12, 0. Let theta be the angle between the x-axis and AB. Find the sine of theta and the cosine of theta. So this is just asking us to draw a picture. All of my points are telling us our triangles in quadrant 1. How do I know that? None of my points have negatives in it. So if we make the point 0, 0, 12, 5, and 12, 0. So here's A, B, C. Here's my triangle. This side is 12, this side is 5. So they're giving us the coordinates of the triangle. Notice it's a triangle that would give us an angle here, right? So the angle between the x-axis and AB, here's AB, here's the x-axis, here's my angle, right? Remember, angle is always going to wind up being close to the origin. To find the sine and cosine, we're going to need the hypotenuse, so we have to do that old friend of ours again, the Pythagorean theorem. I don't know the hypotenuse. So we should get 13. So we now know that the sine of theta is the opposite of theta, which is 5, over the hypotenuse, which is 13. The cosine of theta is going to be the adjacent side of theta, 12, over the hypotenuse of the triangle, 13. Now, I know it doesn't ask us this, but this is also the coordinate where this line segment AB intersects the unit circle. So if I was to draw the unit circle in here, it'd be really, really small if you think about it. This coordinate where the unit circle intersects this point is going to have the coordinate of 12, 13, comma 5, 13. Because remember, the point where the unit circle intersects from that angle is always the cosine of the angle, comma the sine of the angle. That's a little extra tidbit for today. All right, let's take a look at number 4. Number 4 tells us the cosine of an angle is -4/5, and it's in quadrant 3. Find the value of sine. So we have a quadrant 3 angle. So when I draw my x and y axis, I want to exaggerate quadrant 3. I'm going to draw a triangle in quadrant 3. Remember, you're always going to have a theta here. So if the cosine of theta is -4/5, I know the adjacent side is 4 and the hypotenuse is 5. I'm ignoring the fact that it's negative for now because I need to make a triangle. To find the missing side of that triangle, I'm going to do the Pythagorean theorem. So we know how to do the Pythagorean theorem by this point, I hope. So this missing side is 3. Now, in quadrant 3, what do we know about sine? I know sine of theta is negative. So we can say the sine of theta here is negative, the opposite side, which is 3, over the hypotenuse, which is 5. Remember, you're not going to be able to find the sine just from looking at the triangle. The triangle is going to have all positive pieces. You need to know the rule because of what quadrant we're in. Number 5 is using what I just did up here in number 3 in green, knowing where the points are on the unit circle. So if this is a point on the unit circle, the sine and cosine value are coming from this point. Remember, the first part is the cosine, the second term, or the y value, is the sine. So you could say the sine of theta is equal to 2/3. The cosine of theta is equal to negative square root of 5/3. And just from that coordinate, and knowing what we know, what's positive and what's negative, I even know this is going to be in quadrant 2. I know all of the sides, so I can even draw this picture. I know it didn't ask me to do all this, but I just want to show you what you now know. Right? I could draw the picture. It's in quadrant 2. I know it's a triangle that comes out like this. I know the opposite side is 2, the hypotenuse is 3, and the other side is square root of 5. So even though it didn't ask me, I can even find the tangent. The tangent is the opposite over the adjacent, and we know tangent's negative. So we can even do all of that stuff with this. It didn't ask me to do all of that, but we could if we had to. Okay, we could if we had to. Okay, questions? I hope not. All right, hopefully you got a lot of that right on your own, and I will see you all soon.